My topic for this demonstration competition is a vision language approach to chemical pattern table question answering. My supervisor is Estrid He and Dr. Zhang Li. Dr. Estrid. So here's the outline of the presentation today. I will start by diving into the problem formulations. So the problem formulation I put on the slide here, there's two kinds of the challenge is that chemical patterns they are rendering as image, and the query is the natural language questions, and the output is the exact chemical value with unit corresponding with the reasoning of how model doing it. However, when doing this one, there's several key challenges that need to be addressed. First of all, is the OCR noise in scanned pattern PDF. Secondly, is the complexity of layout of table and merge header, as well as the high sensitivity of numeric and unique error. So as you can see, all right, so I will moving on to the related work. So here's the previous work have been done in this field. However, they are not totally focusing on chemical pattern. So you can see there's table LM specialist, which are changing the LM on table of focusing task. There's table vision language benchmark. There's several things like TAP PDA, TAP EVA, and TAP PASS and TAP REP. All of them aim to focus on enhancing the LM capability of doing table relating tasks. So let's move on to the design choice of this one. So in order to do this project, there's 4 design choices. First of all, you need to choose a vision language based model. In our case, I would choose WEN free VL because they are currently the best model in performance. I am aware of that there's multiple models such as DeepSeek, Kimi, and other things like Minimax. However, they got into some ethical issues, so I'm just using WEN here. There's vision encoder fine-tuning, and then the fine-tuning strategy. So I choose 2 strategy, which is the generator validator and multi-stage training, doing supervised fine-tuning and then doing GDPO. So I have explained the reason why I'm doing the WEN free VL here. Overall, they are open source and they are best performing on the market right now. Fine-tuning is they have improved 3 things. First of all, is they need cell localizations, chemical notation recognition, and header value alignment. And the pattern, chemical pattern is different from generic documents, so there's some layers of complexity into that. You might ask why not fine-tuning text-based versus text-based versus visual image-based, because according to relevant studies, the fine-tuning with image use better result when compared doing text-based. You might ask why fine-tuning model instead an agent system, right? So for this task, they need exact numeric and correctness. They also need to be deterministic, and they just need to large scale and stuff like that. So the agent system, although they have multi-step toolchain, but the more complexity you add into the system, the more failure you introduce. And also it's also non-deterministic, and it also costs high effort cost. So this is the training pipeline for the supervised fine-tuning and GDPO, pretty straightforward. The reason why I choose this design because I'm referencing the technical specifications of DeepSeek R1. They need reinforcement learning. They need an initial policy. So without supervised tuning, the reward on spares and table. So by seeding the model with supervised fine-tuning, we give it grounding and define some output format and constraint as well. So I will skip this slide here. So you might ask what is GDPO? GDPO is actually a technique based on GRPO. This just introduced on January 2026 by NVIDIA. So basically, instead of organizing everything into one chain reward, they decouplet and normalizing each individual reward function individually. So this technique is currently yield the highest performance. So I adopt this one. So I skip over the slide. So in order to do GDPO, I need a reward function. So I reference this paper. It's called Rubrics as Reward Reinforcement Learning Beyond Verifiable Domain by the team of Scale AI. So basically, there's multiple rubric for example, exact factual correctness, reasoning validity, conciseness, and contextual relevance, and then formatting and strong negative signal for fabricate or misaligned value. So here's corresponding to the weight. You might ask why do we not fine tuning this exact way? So you can also So you can treat this one as an optimization problem, but however, due to time constraint, I just using the exact way as given in the paper. So the essential one will be the chemical QA because you want your model to have correct answer. And then following up by the reasoning quality, the concise of the response, and the style, and then some verification if the model hallucinates. There's also another technique I want to explore, which is generator validator fine-tuning by the team at Microsoft. So essentially, this one, it's just pretty straightforward. Instead of doing GRPO through complicated algorithm, it's just a generator and a validator. The generator generates the candidate QAs, and then the validator verifies the correctness. So the hypothesis here is that the more iterations of generating and training the generator and validator pair, the better the response will be. So the setup here, I use 3K of the domain-specific table, and then I use 4 refined iteration as given in the paper as well. So here's my data pipeline. I got the pattern PDF. I extract the table image using when Tim also released the OpenVR model. So I using that. I adopting that technique and then used for SFT and GDPO for ablation study. So regarding my my metrics, so I use 2 things. First of all, is BERT score. So it's compute semantic similarity using contextual embedding. They allow for paraphrase, and this allow partial credits for paraphrase while penalizing factual drift. And I also use agreement score, which is measure the consistency between the model output and then trust the references. You might ask, how do I get trusted references? Do I involve subject matter expert? The best practice, we should involve subject matter expert. However, there's another thing. It's called I forgot the name of this term. Sorry, but basically you ask multiple of different LLM to generate the answer, and then you aggregate it using one strong competitor model, one strong model. So there's that. Here's my matrix. Here's some formula. Here's the result. So so I try to approach. So the generator approach performs slightly better than the supervising tuning alone, but for some reason I still try to figure it out. Why supervising fine tuning yield better result than the supervising tuning with GDPO. However, regardless of which approach you to fine tuning, definitely yield better performance than the raw version of the model. I also tried fine tuning one model. It's called LavaMed. with the similar technique. However, the result, because they based on lava architecture, the result is lackluster. So this there, and the highest performance is GPT or SS120B image non-fine-tuned. Again, the similar patterns for the agreement score. You can see on this graph over here. All right, so after doing all fine-tuning, you might ask about what if, however, if you want verifiable grounding, for example, some system citing source. So for future directions, although the model correct is enforced via generator and validator, it provides strong internal consistency, but it's not guarantee external factual verification. So the future work would be integrating a RAG-based module for retrieve the source of the pattern for text and the table regions, and it's also enable explicit verifiable groundings beyond the model internal agreement. So here's the references. And that is the end of my presentation.
Thank you very much. Thanks, Thomas.